Alright, so, I had saw this video from Numberphile literally last night when I couldn't sleep. And it's this video here. He says the number in the video, so I'm just gonna... Here it goes. This is the video.
357 sextillion, so it's already going to be big. 686 quintillion, 312 quadrillion, 646 trillion, 216 billion, 567 million, 629,137.
And he explains in the video the reason why this number is so special is that it's a prime number, and every time you get rid of a number on the left side, it's still a prime number. So if you cover up the 3, this 57 sextillion number is also a prime, and it keeps going down until, of course, you're left with 137, 37, and then 7. And I want to write a script in Python that can create numbers like this, and I want to see if I can get this number. I want to challenge myself and do it in, I guess, an hour, because that's the amount of time that I have left until I have to upload the video. So let's see how this goes. So let's see. Directional, because the other thing he talks about in the video is that numbers that truncate in the left side, the left way, so covering up the rightmost number, and it's still prime. So I'm going to do directional truncated prime numbers. Okay, so the first thing that I need to do is discover whether or not a number is prime. I know that there's definitely a code that does this automatically, but I want to do everything myself. So determine if number is prime. I'm gonna go ahead and just import math. Yeah, just import math as m straight away, because I'm going to need that. And I'm going to go ahead and put this in here, and I'm going to say directional truncatable prime numbers. Alright, so determine if a number is prime. I'm going to go ahead and def is prime, and I'm going to write this function as follows. Alright, so is prime num. Basically, how I'm going to figure out is if it is prime is I'm going to I'm going to go from num divided by 2, so half of the number. Ooh. So basically what I'm thinking is this. I'm going to get the number, I'm going to divide it by 2, and then I'm going to check all the numbers. No. I should just go from... Alright, so I'm going to have a max number. Max num. And that's going to be the result of the division. So I'm going to go max num equals inf. Is that? No, okay. I'm pretty sure there's m dot max number somewhere. Let's go ahead and look up the terminology for that. Sys max size. There we go, 6 max size. So I'm going to set this maximum number as the maximum size. Hang on a sec, I just got to get this mic in the right position. Alrighty then. Alright, okay. So I'm setting the max number as that, and then I'm going to set divisor as 2. I'm going to set the divisor as 2. That's going to be the starting one. So I've got my two variables here. And basically what I'm going to do is that I'm going to check if... so I'm going to go while... I'm going to go result equals 0 to get it into station as a number, and I'm going to say while result is less than max num, right? That's result. So I'm going to go while result is less than the max number, I'm going to divide num by divisor. So result. Wait. Hang on, no, that's not right. No, while divisor is less than max number. So I'm going to divide num by divisor. Okay. These both have to be floats. So I'm going to go ahead and cast them as floats. Because if they're not floats, then they'll just round off to an integer. And I'm looking to see if the number is a whole number, and the way I'm going to determine that is if result mod 1 equals 0. So basically what this does, what a modular is that it divides the number by this number and determines if there is any if there's any remainder. And what mod 1 will do is determine if there's any decimals, at least it should do. So if result is 1, I'm going to go ahead and just break out of the function immediately, because if it divides by something that isn't a decimal, then the number isn't prime. So I'm going to go return false. So the number isn't prime. Okay, so next thing I'm going to do is I'm going to set max num as result. Set max num to result. And then I'm going to increase the divisor by 1. There we go. So now what I've got here is a code that will continuously check the number divided by the divisor and make that the default the result. And if this result does not have any decimals, then it will return false. So it will break out of this entire function and return false. But if the maximum number, and then if it is a decimal, so if it doesn't divide by that divisor, it will set the maximum number to that result, because if I've got a number, say 1000, and then divide it by 2, it'll get 500, and that's like the maximum possible number that I'm going to get, because when I go up to 3, that number's going to get smaller. It's going to go to like 333 or something like that. And so basically what I've got is these two walls that are going to collapse into each other, and as soon as my divisor is greater than my max number, I'm starting to go in the opposite direction. So, my bigger numbers, eventually I'm going to get to like a divisor of 500, and my max number is going to be, and my result's going to be 2. But I don't need to worry about that because I've already checked it, because 1000 divided by 2 is like, 1000 divided by 2 equals 500 is comparable in this sense of saying 1000 divided by 500 equals 2, because if you can divide one number one way, you can divide it the other way. So therefore, I don't need to worry about all the like half of my factors, because pairs of factors will cancel out each other. All right. So this will make sure that it doesn't check too many times, and it'll check all the results. So let's go ahead and see if this works straight away. Oh, invalid syntax. Nimpt. Oh right, of course. I need to do that. That's right. I was doing the C# casting method. That's not correct. So I'm going to go ahead and make those floats, and then I'm going to press F5. Invalid syntax. Okay. Equals. There we go. All right, sweet. So truncatable numbers. So I'm going to go ahead and ask, is prime 2? Shit. All right. Import sys. Go ahead and do that. All right. So is prime 2? False. It is not prime, because 2 divided by 2 equals 1. I'm going to go ahead and put in another one that if... No, okay, so if result... So if the result mods 1, right, equals 0, and result and not result equals 1. Okay, so if the result doesn't have any decimals and it's not equal to 1, so therefore 2 will be a prime number, it will return false. So let's go ahead and see if that works. Still says false. All right. Because I've only got a return false here. I don't have a true statement. All right. So if you break out of this loop, if you at any time break out of this loop, then you've checked every possible factor up until you've the walls have collided with each other, and you will return true. So let's see if this works now. All right, it is prime. 2 is a prime. Let's see, is 3 a prime? Yes. Let's see, is 4 a prime? No. Okay. So I'm going to go ahead and write a simple script here. I'm going to go for range. I'm going to stop at 100. Oh, what? For range. No, sorry. For I in range. There we go. Silly me. Forgetting how to write in Python. All right, so for I in range, I'm going to print I. I'm going to print that plus I str. I'm going to do it proper way. I plus is prime question mark. Now I'm just going to like that, and then I'm going to go plus str is prime I. So go ahead and do that, and then I'm going to print that, and then see what happens. All right, so we can see all the prime numbers being written out. 1 is prime. 1 is not a prime number. I'm pretty sure. I'm not sure. 1 is up to contention anyway, but that's not what we're worried about. We're not gonna use 0 and 1. But 2 is prime. Yes. 3 is prime. 5 is prime. 7 is prime. 8 is not. 9 is not. 10 is not. 11 is. 12 is not. 13 is. So our system works. We can go all the way up to 99. So that is not a prime number, which is true. But 97 is a prime number, which is true. And I'm going to go ahead and see if I can do this for incredibly massive numbers. So I'm going to go ahead and plus, let's say, just a whole bunch of 9s and 0s. Let's see if that works. If that's even possible. So let's have a look. So it does it. My function does it immediately, which is very good. Even though this number is very massive and the two walls would have a long time before they reach each other, since I've got, I think it's basically just because I've got the, since these two walls approach each other incredibly quickly, it's really, really optimized, which is really nice. All right, so so my code works for that, and of course, if I try to run it for any more numbers, then what's going to happen is that I'm going to get like the actual printing to the screen is going to be a lot slower than my function that I've created to determine if a number is prime. Okay, so we've got a function to determine if a number is prime, and what we can do here to start printing all the prime numbers is I can go for that. Okay, so I'm going to go I equals 0 for x in range. I'm going to say up to 1 million. That's 10 million. So up to 1 million range. I'm going to go, okay, so if x is prime x print x, and I'm going to go end is going to be comma space. So let's go ahead and do that. So now it's printing out all of the prime numbers. And you can see it's going to get slower and slower and slower as the text fills the screen, because I'm not sure if that has something to do with Python's like text displaying code getting more and more filled with these numbers, or if it is actually, or if my code is actually taking a longer time. So we can see that all of the prime numbers are being generated, and this is actually pretty dang cool, because I didn't expect the determine every number as prime number was going to be that easy, but here we go. Here's all of the prime numbers up until a million. We've only got to 12,000. This is going to take a while, so I'm just gonna impeach my honor here and say that it's gonna work. Okay, so I'm gonna go ahead and restart the shell so we don't have to wait until 1 million. Well, actually, what I can do to determine how long this is going to take, ready? I'm gonna do a smart thing. Instead of doing this, I'm gonna make I equal to a quote, and then I'm gonna go ahead and I'm gonna run this, right? Sorry, make I into a quote, and then I'm gonna put this down, and then I'm gonna go, instead of print, I'm gonna go I equals strx plus that. Okay? So it's thinking, it's doing all the numbers up to 1 million, and we're gonna determine how long that's going to take. So I probably should have started a timer, but I'm just gonna say 3 seconds, 5 seconds plus the current Audacity time you can see here. So let's go ahead and see how long this takes. Because like the number that's in the video, 37 here we go, it's done. Oh my god, that was quick. That was 30 seconds. I to 1 million. So I'm gonna go ahead and see what I is. Whoop. Oh, silly me. Dingus. All right. Oopsie daisies. I'm gonna go ahead and go like this. Okay, Control C. I'm gonna make I equal to nothing again, and then I'm gonna do that. All right. Let's see. Okay. So again, I've started at 17:56. So 4 seconds have passed, and it's going to be 18 minutes plus 4 seconds. Or it's going to be whatever the time is, whatever the seconds is plus 4 seconds. So I'm going to assume that it's going to end at about 18:26 is when this is going to finish. And then I'm going to display the number, and we'll see what happens. So we're up to 18:20, 1, 2, 3, 4. There it goes. It's done. All right, sweet. So now we're going to display what I is. Shit, I just erased everything. Fuck's sake, I'm an idiot. So 1835. So let's see if this gets done by 19. I can't believe I did this. Oh fuck, I can't believe you've done this. Alright. Here we go. And 19, 1, 2, 3, 4. There it is, it's done. Alright, so now I'm going to display I. And it's thinking. Ooh, okay, so there we go. It's the squeeze text. And let's see if... Oh, jeez. Alright. Let's not do that. How do we copy the text? Right click from option, copy. Alright, so I'm going to go ahead and go into Notepad. And I'm going to go ahead and just print the text. Alright, here we go. So these are all of the prime numbers going up to 1 million. And it should be. If I just pick any random one here. I mean, all of these past the is this number prime function, so yeah. So I guess, yeah, I just have to like assume that these are in fact all of the prime numbers. All right, so, whew. So here is what I'm going to do. Okay, so I've got a code that determines whether or not a number is prime, which is pretty dang awesome. and it is a brute force code. I don't have an exact formula to do it quickly, but this is just a brute force code to determine whether or not a number is prime. So there's two ways that I can determine how to make a right truncatable prime. What I can do is I can build a number, get a number, and then make a script to determine if it is right truncatable by just truncating the left digit and then seeing if that number is prime and continue going until I have no more numbers left. That is possible, but it's going to run through every single number that exists. And, you know, we're talking about 357 sextillion here. There's a lot of zeros to go through. So I'm not going to do that. That'd be silly. The second way I can determine is to build a number that is continuously prime from the left to the right. And the way I can do that, it's going to be like a pseudo AI sort of thing. But basically what I'm going to do is that I am going to get a list of numbers, right? So I'm going to go def build list. I'm going to go def build list, and I'm going to allow a input list to be I'm going to say starting list. So starting list, and I'm going to make that a default empty list. Nah, actually I'm just going to put it in starting list. Okay. So for starting list, I'm going to run through each item of the starting list. So I'm going to go I'm going to build another return list. So that's going to be an empty array, and I'm going to go for each in starting list. I'm gonna just call that list with capital L, because lowercase l I think is already something. Yeah, lowercase l is already something. So for each in, I'm just gonna call it R. All right. So for each in R, right? For each element, what I'm going to do is I'm going to iterate through the numbers 0 to 9, and I'm going to add that to the left to determine, and I'm going to check if that number is still a prime. So I'm going to go ahead and say, all right, for each in R, I'm going to go for I in range 10, because range 10, if I just go like this, should print all the numbers. Oh, god damn it. You cheeky bastard. Alright, so I'm going to go for I in range 10. So for I in range 10, I'm going to go like this, and I'm going to print I. So there we go. So those are all the numbers from 0 to 9, which is what I want. So I'm going to go for I in range 10, right? I'm going to go, I'm going to put this, I'm going to make a num equals 0. And then what I'm going to do is that I'm going to build a number, which is going to be, so this return list, so I think I'm going to deal in, so I'm going to say, make a comment, because I need to comment and build the list that contains all of the thus far calculated right truncatable prime. All right. Actually, no, that builds all right, I want to be able to find all of the right truncatable primes, and the way I'm going to do that, and hopefully I'll end up with this number here. So that's my goal. I'm going to make a function that builds every single right truncatable number that ends up with this. Now in the video he does display all of the right truncatable numbers, and he starts left truncatable numbers I meant. So these are all of the left truncatable numbers, and it keeps going upwards and upwards, but I'm going to try and get that list, but in Python, because out of a program I wrote myself. Okay, so I'm going to go ahead and, so this is a string, so what I'm going to do is I'm going to go num equals int, and I'm going to go stri plus each, because the R is going to be an array of string, and so I'm going to add the number that is between 0 and 10. I'm going to add that number onto the thing and convert it into an int, although it doesn't really work with 0 itself. So I'm going to go ahead and add, I'm going to go ahead and say include 0. And I'm going to make that false to begin with. So I'm going to go ahead and say if include 0, so if we're not including 0 and I equals 0, if we're not including 0 and I equals 0, I'm going to go ahead and say continue. There we go. No worries. All right, so now the number is going to be casting an int, turning the I into a string and adding that onto the left side of the number that's out of the array. And then I'm going to determine if is prime num. So if the number is prime, and only if that number is prime, we're going to add that number into the return list. So return list dot append. Okay, that's not the right one. I keep forgetting what the exact thing is. So no. I can just go return list plus equals this element that is the string of num. Here we go. There we go. Because if I have one list and I add another list, hopefully that'll make a list of 2 elements, which it does. Okay, so easy peasy. So return list plus equals a string number. All right. Of the next numbers which are left truncatable. I think I should do left or right, but that's going to be a simple change. It's just going to be which side you put the number on. In fact, I'm going to do that right now. So I'm going to go ahead and make this one say left equals, I'm going to go left equals true, and I'm going to say if left. So if it's left truncatable, then it's going to be like that. If it's not left truncatable, then it's going to be the opposite direction. So instead it's going to be each plus that number, the string, the I, left or right. So left truncatable numbers is if you remove the left number, right truncatable numbers if you remove the right number and it's still prime. So if that number is prime, then it's going to return that list. Oh, my neck. All right, it's going to return that list plusing the time. It's going to be the next numbers. So if I have a list of 0 to 10, it's going to return all of the numbers that are prime based off of adding the numbers to 0 to 10. All right, so this is going to be a brute force sort of array. You can tell because I've got 2 for loops here. It's going to be going through each number of the array, and then on each number of the array, I'm going to add a number to that number. I'm going to add the digit to that number. So it's going to be brute force, and I'm not sure if this is going to be a easy one. But let's see if this works. So I'm going to go ahead and try to make this a thing. All right, so I'm going to go ahead and make setup function to run program. Make setup function to run program, yeah. And what I'm going to do with this setup function is that I am going to essentially make a script or just return the I could just do it right now. So 0, all of the numbers that are. Sorry, actually, I'm just gonna do it. I'm lazy. I am very lazy. So for I in range 10, I'm going to ret equals empty list. For I in range 10, ret plus if I is prime, may as well just add that extra level of primes in there. It's going to reduce the amount I have to do anyway. So if is prime I, I'm going to go ahead and return. No. If I is prime, ret equal plus equals str I. There we go. So for the numbers between 1 and 10, if it's prime, add it to the list and then return that list. Okay. So make a setup function to return the initial list. Alrighty then. So, so I'm gonna go ahead and research just to figure out Python main function. Alright, main function. Alright. It's this one here. Using default values. Here we go. So I never remember this thing, but that's what you want to do. So that means that if I run this script, it's just going to print it's just going to do whatever's in here. So if I print hello, so if I do that, it's just, invalid syntax. Oh, right, of course. Make sure the code actually works. There we go. It's just going to print it's just going to do whatever's in here at the start. So that's as soon as I run the script. So that means I'm going to go, all right, so R equals setup. Yep. And then I'm going to do, all right, so, so I'm going to do something really tricky and silly. I'm going to do something that's very silly indeed. So while R count R is greater than 1, so while there is more than one element in this array, yeah, so while there's more than one element in this array, I'm also going to build a number list string. So that's going to be like this, equals that, and then I'm going to do for each in R number list. I'm gonna turn this into a function. I'm gonna call it make the string building function. Alright, so I'm gonna make that function to build onto a string. Function to build new elements onto a string from an array of string. Okay, so I'm going to go ahead and do this. I'm going to say def build build string. I'm going to say string. Actually, I'm going to call this R. Okay, so basically what I'm going to do is I'm going to go return equals empty list, or empty string, and then I'm going to go, actually, fuck it, I'm going to go orig R, like this, and I'm going to go if len orig greater than 0. So if it's not empty, I'm going to add a comma and a space onto it. Okay. And then what I'm going to do is I'm going to do for a in R. I'm using very arbitrary variables for the for loops, but that's going to be okay. So for a in R, orig plus equals a plus no. I don't need to do this, I don't think. I'm gonna go ahead and comment this out. I don't need to do that because I can do this. There we go. So now it will add every element with a comma between it or before it. Okay, and then I'm going to return orig. Okay, so now our number list is going to equal build string from empty, and the array is going to be R. No worries. So that's that. So now, while my count of R is greater than 1, I'm going to go ahead and make R equal to build list. Okay? So here's build list. I'm going to lowercase b because I'm an idiot. Capital B here. So I'm going to make R equal to build list. I haven't actually tested build list before. Oops, silly me. So I'm going to go ahead and comment out the main here. Actually, I'm just going to comment out this. I'm going to go ahead and test a build list. That's probably something that's really important to do originally. So build list. I'm going to run the setup function. Should already be set up. Yeah, so if I just R, so 1, 2, 3, 5, and 7. Those are my prime numbers. Okay, so 1, 2, 3, 5, and 7. So what I'm going to do is this. I'm going to go ahead and test out my build list function using this R. And it's not going to include 0, and it's going to be left truncatable, so let's see what happens. Alright, so I'm going to go R equals build list. Silly me. Alright, so let's see what R becomes. Empty. Right, okay, so there's something wrong with my build list. Alright, so oh, I'd never return anything. I'm a fucking idiot. There we go. Now it should work. So I'm going to go ahead and do this, and I'm going to print what R is. All right, here we go. So these should all be prime numbers. 11, 31, 41, 61, 71, and then 13, 23, 43, 53, 73, 83, 17, 37, and you see here's the 37 that's in this number. If we just go back to the number that he's... So here's that 37 that is in that number, 37. And now, if I do this again, just run the script again, I'm going to build even more truncatable primes. So if we look for the next number, which is actually 137, so if we come over here, it should be at the back here where the last number is 7. So here's 137. Now, I just realized a flaw with my code, and that the numbers that you make are not actually going to be in order, which is a bit of a shame. But we are building left truncatable primes. You know, 211 is prime, 11 is prime, and we're considering 1 as prime. Although, hang on, let me just Google real quick. Is 1 a prime number? Okay, so but you see, okay. So the count of positive divisors is 1, so itself, so it's not a prime, alright? But a prime number is that is divisible by 1 and itself. That's what my definition of a prime is. And the primes of 1 is 1. So a prime number is a positive integer whose positive divisors are exactly 1 and itself. Both of those events are true. It is both 1. There is one, the factor of 1 is 1, and it is also itself. It's 1. Okay, but the consensus seems that a prime number 1 is not a prime number. Okay. Yeah, right. So therefore, I'm going to have to get rid of 1. So I'm going to put another thing in here. I'm going to go include... Actually, no. It's going to be my setup function. And I'm going to make this include... Oh, no. It's going to be my prime number is prime. And I'm going to basically say... if num equals 1, return false. Alright, hang on. No, I should just do it once. Yeah, there we go. If num equals 1, return false. That makes me angry for some reason. 1 should be a prime number. 1 is a prime number. Come on. Its factors are 1 and itself. And I'm talking that in the, I am talking about that in the Boolean logic determination of the phrase 1 and itself. The factors of 1 is 1. It is both 1 and itself, so therefore 1 is a prime. That makes me angry. That makes me irrationally angry for some reason. Okay, so we've got this function here that builds this list. All right, so now that I've fixed up that little annoyance, I'm gonna go ahead and see if it does it again. So I'm gonna go ahead and select display. Okay, so 1 is no longer a prime number, which makes me angry. It makes me very angry. Alright, so here we go. So R is slowly building, which is good news. My only gripe is that it's not going to be a, it's not going to be in order. Which is a bit of a shame, but at the end of the day, it's whatever you get, you know? Alright, so what I'm actually going to do, I'm not going to build string. That's silly, Steve. That is silly. I'm going to go ahead and do number list plus equals R. So this is what my function is going to be. While count R is greater than 1, build list and then number list plus equals R. And then I'm going to order it. I'm going to sort it using a sort script that I designed before, which is an average partition quicksort. Which is a nice like gooey bloody thing. So number list equals empty array. Okay. Actually, no, it's just going to equal R to begin with. There we go. which is like it's a nice little algorithmic programming sort of language that I can use. I've developed a sort which is an average partition quicksort. There we go. So yeah. Okay. So let's see what this does. And at the end of this main function, I'm just going to go print number. Oh, I'm gonna print number list. Here we go. Fuck. Count is not defined. It has to be len. I forgot that. Go. Function object is not iterable. A function object. Oh, whoops, silly me. Build list wasn't a function. It was just saving that as that's strange. That's my fault, not Python's fault. All right. Build list missing one. Oh, right, silly. Here we go. Now it's doing its thing. All right, so it's just going to be trying its best. It's going to be trying its best. And we're going to see... Oh, man, I just realized getting up to... Oh, well, technically it's not going to take that long at all. Getting up to... Technically, no, not really, yes. So this is basically what I'm thinking that it's going to do, and why I don't think it's going to take all that long. So, it's starting at the right side number, and it's determining if those numbers are prime before adding it onto the left side, which means that it's quickly it is quickly erasing branches that would take too long to consider out. Especially if I went from just going to 0, adding 1, and determining if that number is still prime, and determining if that number is truncatably prime. In doing what I'm doing here, I'm essentially making it so that it only considers the numbers which are continuously truncatably prime. Which means that there is at most 10 possible branches for each of these numbers, which means that there's 10 possible branches for the previous numbers. But basically, I'm going to end up with a script with a list.
So it's always prime when I truncate from the left. So it's
like
going to left
this.
Truncate
These are all. This is the list that I'm trying to generate.
Finitely many of them, and that is the largest one. And I learned.
There it is. So I'm gonna get a list that looks like that with all of these in it. And it's taking a goddamn while. I should probably have done a lot more tests to determine if this function actually works. Okay. I'm going to go ahead and cancel this right now. And what I'm going to do is I'm going to make a build string. No, not a build string, because I'm not using that anymore. I'm using build list with my R being just the digit 2. So the build list of it is just going to be the digit 2. And it's going to be an empty. Excellent. That's what I was expecting. If it's 3, there's going to be all of those numbers which are prime. And if it's 4, it should also be empty. Yes. If it's 6, it should be empty. Yes. If it's 8, it should be empty. Yes. And of course, if it's 0, it should be empty. There we go. All right. So that means that it's getting rid of all of those numbers immediately. I'm only ever considering half of the possible space. I'm going to go ahead and only do it to a certain amount of numbers. So I'm going to go ahead and put an AND loop is less than, say, 1,000, just for now. So I'm going to go ahead and put this in and go loop equals 0. And then I'm going to make loop plus equals 1. All right, so let's see what happens. It should go pretty quickly. All right, I'm really impatient when it comes to not knowing if my program is actually doing something because I'm afraid it's stuck in an infinite loop. So what I'm going to do is I'm going to slow the program down like nobody's business, and I'm just going to go ahead and say print R. There we go. That's going to slow the program down massively. So let's see what happens. Here we go. It is continuously printing all of the left truncatable 9s, and it's just going to squeeze the text because there's too much text. Here we go. 58. Oh boy. My quicksort, my average partition quicksort is adequate to the point where it will be able to sort these massive numbers very quickly. So it seems like each text number is going to get slower and slower, which is understandable because it's 51 lines of numbers which I am checking every single factor of that number to determine if it is prime. So it's going to take a long time, and I'm not sure whether or not it's going to do this in a reasonable amount of time. But there's that, because it seems to be getting exponentially slower, which is a problem. I realize doing it to loop 1000 is a bad idea because that's checking 1000 digit numbers. So I'm going to go ahead and make this loop. Well, hang on. What's this one? Loop 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So it's 24 digits is the maximum. So I'm going to go ahead and make this loop 5. So I'm going to go ahead and do that and see what happens. So this is 1, 1, 2, 3, 4, 5, and it's ended. Okay. So this is the full list of truncatable primes that have 6 digits or less, which is pretty dang cool. The only thing I need to do now is sort it, and I'm going to go ahead and see if I can find my average partition sort. Go ahead and open file location. No, I'm going to go ahead and okay, so I think it's in my documents folder, and it should be Python 2.7 projects. No, that's my RuneScape bot. Damn it. Where did I put it? Because I know I created it in an absolute huff. Actually, no, I'm not gonna create. I'm being silly. I don't need to do that. I can just go like this. Sorted. Here we go. I'm being silly. All right. So if we do that, the numbers are, or now should be sorted. We go like this. Here we go. 13, 17, 23, 37, 43, 47, 53, 67, 73, 80. Yep. So this is now a sorted list, which is handy dandy. Alrighty then. So now what I'm going to do is I'm going to get rid of this print, and I'm going to say, I'm going to put in debug statements. So I'm going to go print checking. Go ahead and put in checking numbers that are loop +1 str loop +1 digits long. So I'm going to do this, go like that, and then I'm going to go print. Oh right, I need to close this bracket. Silly me. So checking numbers that are that long. Str len r plus digits found all right. Numbers, prime numbers found. Number list, sorted array, and then I'm going to go print total plus str len number list total found. Like that. Okay. And then I'm going to print a bunch of new line characters because I like doing new line characters. All right, let's see how it goes. Oh, silly me. Try that again. All right, there we go. 1 digits long. Oh, right, I didn't iterate loop. Silly me. Try it again. There we go. Oh, loop is less than 5. Right, I'm going to get rid of this one. Here we go. There we go. So there we go. So the number of these digits are slowly increasing. And you can see that as soon as we get to 8 digits, the program slows down massively. 9 digits. All right, so I'm going to go ahead and put this timer next to it. Here we go. Actually, I'm going to go ahead and build in a timer in this function here. So I'm going to go import time as t. Nah, I'm not going to put a timer in there. That's silly. 10 digits long. I'm going to have to wait until this brings to 24 digits. So that is an hour of coding. And it seems like my thing is working, and I'm going to determine whether or not this is successful. And I'm just going to let this play out so you can see how long it's going to take. And that'll be about it for this video. So thank you so much for watching this video. And I'm actually quite proud of the fact that I managed to make an intuitive function that determines whether or not a number is prime. It is a brute force function. I don't know if there's any formulas to determine if a number is prime, but it is a brute force function, but it does determine whether or not a number is prime, and it does so successfully. And I am proud of the fact that I actually managed to make a list, which actually I'm going to say build find truncatable primes. Here we are. So I'm going to go ahead and do this. I'm going to make this one find truncatable primes. I'm going to go ahead and copy this because I'm terrible at spelling things the same way twice. All right, sweet. All right, that's going to keep going on the previous thing because it's already been running. But anyway, so I'm happy that I actually managed to get this done, and that it's actually doing the thing that I wanted it to. And I'm just going to let this continue going, and it's going to continue recording, and I'm going to see if it actually does the correct thing. All right. But yeah, so thank you so much for watching this 1 hour of coding video. 1 hour of programming. I don't know what I'm going to call this. But yeah. Yeah. Thank you so much. I'm not sure. I'm just looking at the timing. I'm not sure if I should stall this until it reaches to 1 hour exactly when I say goodbye and good luck. But you know, that is that, and that's what is currently happening right at this moment. This code is still running, and I've got my. I'm also going to include this as a paste bin, a link that you can find so you can make this program yourself, and you'll find that link in the description. Actually, I am just going to get rid of this build string, so that's it. All right, so I'm gonna put a link to this code in the description so you can find it and make some tunings or just use it yourself. But at this current point in time, that is all for this video. So I thank you so much for watching this video. This is Quillo signing out. Goodbye and good luck.